Do you feel the vibes?
So welcome back to Quick Tip Tutorials. This is part 2 of Ohm's Law. So if you didn't check out part 1, I would go recommend you check that out. In that video, we went over just what is Ohm's Law and some of the basic rules to follow. Now in part 2, I'm going to do some example problems. So what I've drawn ahead of time is a series and parallel circuit. And I made it very, very simple. So on the left, I have a series circuit where I have a 9-volt power supply. I have 3 resistors in series. Resistor 1 is 10 ohms, resistor 2 is 20 ohms, and resistor 3 is 30 ohms. All right. On the right-hand side, I have a parallel circuit. So you can see the difference between the two. Series is one continuous path versus parallel has different branches parallel to each other. Again, I have a 9-volt power supply and 3 resistors again. So I have 10 ohms, and that's going to be my resistor 1. I have 20 ohms, that's going to be my resistor 2. And I have 30 ohms, that's going to be my resistor 3 value. So just to show you the differences with Ohm's law in a series parallel circuit, I'm going to find total voltage, total current, and total resistance in each. And in addition to that, I'm also going to find current and voltage across each individual resistor based on the rules that we know about Ohm's law and series and parallel circuits. So let's start with series first on the left. And I'm going to just shift this up a little bit. All right, so I have a series circuit. So the first thing I like to do with Ohm's law is I'm looking for total voltage, current, and resistance. So let's see what values I already know. So I'm going to say voltage T, so total. I'll write it out. Voltage total is 9 volts. Pretty straightforward there. All right, current total. We don't know that yet. And resistance total, right? That's equal to, as we said, just adding up the resistors. So R1 plus R2 plus R3. So in this case, it would be 10 plus 20 plus 30. And if we add that up, we get 60 ohms. All right. So based on Ohm's law, to find current, right, total current is equal to voltage divided by resistance. So let's do a little math here. Right, current we're trying to find is equal to 9 volts divided by 60 ohms. All right, and let's shift this up so we get a little bit more room. And I'm going to get my calculator out really quick. And if we do 9 divided by 60, this is giving us 0.15. So current is going to be equal to 0.15 amps. All right, now voltage is measured in volts, current is measured in amps, and resistance is measured in ohms. So in this case, I have a total current now of 0.15 amps. Pretty straightforward there. All right. Now, that's important to know because we know that current is constant in a series circuit. So let's do this now. Let's slide this up even further. And let's try and find voltage at resistor 1, voltage at resistor 2, and voltage at resistor 3 versus current at resistor 1, current at resistor 2, and current at resistor 3. All right, so we know based on our rules from before that current is constant in a series circuit. So if I know that my total current is 0.15 amps, I know that across resistor 1, resistor 2, and resistor 3, my current is going to be 0.15 amps. So this is pretty simple so far. So I could write 0.15, right, 0.15, and 0.15. And again, this is in amps. So that's pretty simple. Now, voltage at resistor 1, there's going to be a voltage drop. Right, we have a resistor in there, so we can't have 9 volts, right, going through each of these resistors. It doesn't work like that. So what we're going to do is we know the voltage going across this resistor here, right, and we know the current, or I should say this, we know the resistance value, not voltage, excuse me. We know the resistance value and we know the current value here. So let's see what the voltage drop is here. All right, so voltage at resistor 1 is going to be equal to current times resistance. So 0.15 times 10 ohms. And voltage across resistance 1 is pretty much going to be equal to 1.5 volts, right? If we do 0.15 times 10, we get 1.5 volts. All right, if we do resistor 2, we know it's going to be 0.15 times 20. And if we do that, we get an answer of 3. So voltage across resistor 2, right, is dropping by 3 volts. And then finally, resistor 3, we're going to have 0.15 times 30 ohms. And that gives us 4.5 volts dropping across this resistor. Now, there's an interesting thing here, is that the total voltage coming out also, right, has to equal, the voltage drops, I should say, should equal the total voltage. So let's look at this, right? Across resistor 1, we have a voltage drop of 1.5 volts. Across resistor 2, we have a voltage drop of 3 volts. And across resistor 3, we have a voltage drop of 4.5 volts. Now, if we were to add that up, right, if we add up 1.5 plus 3 plus 4.5, that gives us a total of 9 volts, which actually works out, right? We have a 9-volt power supply, so we should have voltage drops, right, that equal up to a total of 9. So we know our math worked out. So again, total voltage is 9 volts, but in a series circuit, current is constant, and we're able to find that by total voltage divided by total resistance, and the total resistance was found by adding up the 3 resistors. And then once we add our total current, we know that current is constant in a series circuit, and we could figure out the voltage drop across each resistor, as we know that voltage will drop in a series circuit. All right, so pretty straightforward there. All right, it's just plugging in the values and knowing what you're looking for. In a parallel circuit, right, it's going to be kind of the same but flip-flopped in terms of what we are solving for. So let's do this again. In our parallel circuit, we know the voltage total is equal to 9 volts. Our current total, we don't know yet. And our resistance total, we actually don't know yet either, because we have to figure out what our total resistance is of our parallel circuit. All right, so here's what we are going to do. We have to solve total resistance first, and let's move over here to our formula. Resistance total in a parallel circuit is equal to 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. So let's do the math here really quick. All right, resistance total is going to be equal to 1 divided by 1 over 10 plus 1 over 20 plus 1 over 30. And if we do 1 divided by 10 plus 1 divided by 20 plus 1 divided by 30, I'm actually just doing a little math here. 1 divided by 10 plus 1 divided by 20 plus 1 divided by 30. We get a total of 0.183 repeating. So our total resistance, that's for the bottom portion, I'm sorry. We have 1 divided by 0.183 repeating. So we'll just leave it there. So if we do 1 divided by 0.183, we get a total resistance that is equal to, and I'm just going to round here, 5.46 ohms. All right, so we have two components now. We have our total voltage, which is equal to 9 volts, and our total resistance is 5.46 ohms. So unlike series, you're not just adding up the resistors. So let's figure out our total current now that we know what our total voltage and resistance is. All right, we know that total current based on Ohm's law is going to be equal to voltage divided by resistance. Total voltage divided by total resistance. So if we plug in values, we have 9 divided by 5.46, and that is going to give us 9 divided by 5.46 is going to be equal to 1.6. I'm going to round up 1.65 amps. All right, so I have my total values. All right, so unlike a series circuit, parallel circuit's going to be a little bit more work, but still relatively simple if you follow the rules. So I have total voltage now of 9 volts, total current of 1.65 amps, and total resistance of 5.46 ohms. But now let's figure out what is the voltage and current going across each of these loads. So I'm going to slide this up, and just like I did with my series circuit, I'm going to write voltage at resistor 1, voltage at resistor 2, and voltage at resistor 3. And I'm also going to write current at resistor 1, current at resistor 2, and current at resistor 3. Now, based on our rules, kind of the opposite of a series circuit in terms of in a series circuit, current is constant and voltage drops. In a parallel circuit, voltage is going to be constant and current is going to drop over each load. So I know I have 9 volts. So voltage across resistor 1, 9 volts. Voltage across resistor 2, 9 volts. Voltage across resistor 3, 9 volts. All right. Now, we got to do a little bit of math here again. But again, let's look at what we did in series circuit. It's the same thing, just we're plugging in different values. While current was constant and we did Ohm's law, we did current times resistance to find voltage. Now, we're looking for, we know we have 9 volts across each resistor, and we know the resistor values. R1 is 10 ohms, R2 is 20 ohms, and R3 is 30 ohms. So let's just do some basic math here. Current is equal to voltage divided by resistance. And in this case, the current across resistance 1, we know we have 9 volts divided by 10 ohms. And if we do 9 divided by 10, that should simply give us 0.9. So what this is saying is current across resistor 1 is 0.9 amps. All right, let's do the same for resistor 2. I'm not going to write V divided by R because it's the same thing. In this case, we have 9 volts divided by 20 ohms. And 9 divided by 20 is equal to 0.45 amps. And one last time here, we have voltage, 9 volts divided by resistance, 30 ohms. And 9 divided by 30 is 0.3. So now we know the current across resistor 1, we know the current across resistor 2, and we know the current across resistor 3. Now, we can check our math a little bit here. We know that total current is 1.65. So let's check this out again really quick. If we were to add up 0.9 plus 0.45 plus 0.3, we get 0.9 plus 0.45 plus 0.3 is equal to 1.65. So we know we did our math right because my total current, I said in my parallel circuit, was 1.65 amps. And if I added up the current going across all 3 loads, I know I did it right because my math checked out here. All right. So using Ohm's law, why do we need this? Why do I need to know about voltage and current going across different loads? Well, for example, you would use Ohm's law, and one of the most basic examples is if you have LEDs in a circuit. LEDs have a maximum amperage operating value. If the amperage is too high, it will actually blow the LED. And we don't want to do that. So depending on the power supply you have and the specifications of the LED, you'll need to do Ohm's law to figure out, maybe what resistance you need with that LED so it illuminates but doesn't blow out. All right. And if you're designing circuits, this is also important to know, right? If you have a specific power supply or a specific amperage running through the circuit, you may need this in terms of designing your circuit, what components you need so you don't ruin anything. All right. So, all in all, this is a simple example of Ohm's law in a series and parallel circuit with total voltage, current, resistance, as well as figuring out voltage and current across the three loads. Hopefully this helps. If you guys have questions, please let me know. You can leave it in the comments. And thanks for checking out Quick Tech Tutorials.